I have the solid hemisphere. I think that solid hemisphere of radius r is placed on the inclined plane of inclination theta. What is the maximum value of theta for which hemisphere will not topple? We are discussing about the toppling of hemisphere on the inclined plane. This is hemisphere, what we have. Where the center of mass of the hemisphere will be? Solid hemisphere. I think that this is very important. That particular thing is needed. So the center of mass of solid hemisphere is at a distance of 3r/8. Let's come for this one. This will be 3r/8. What are the forces acting will be mg sine theta, mg cos theta, then the friction. In what direction, about what point it can topple. Now, because of the, let's talk about this one, about center of mass. The torque due to mg sine theta and mg cos theta will be zero about center of mass. Torque due to friction. Torque due to friction will be anti-clockwise. So this particular hemisphere is having a tendency to rotate anti-clockwise. Anti-clockwise. Then who will balance that? If you say normal reaction will pass through center of mass, net torque will become non-zero. So therefore, the normal reaction will start shifting. Then at one particular point, the normal reaction, when about to topple, will pass through the point. This idea is very important. How to check the normal reaction is, I'll put it once again. The torque due to mg sine theta, mg cos theta about center of mass will be zero. Torque due to the friction will be anti-clockwise. Then it is not sliding nor toppling, let's say so. Then we will balance the torque due to friction, the normal reaction. If you assume normal reaction like this, the net torque is non-zero and it must topple, but it's not toppling. So therefore, the normal reaction, in fact, will shift. It will act like this. It will act here. Finally, at one point, when it's about to topple, normal reaction will pass through point A. When about to topple. It is asking maximum value of theta, so the normal reaction will pass through point P when theta is maximum. I think this idea. Will bring the normal reaction. The normal reaction will pass to the this will be mg sine theta. We'll take the net torque about point A. Net torque about point A should be zero. Then torque due to normal reaction Na and the friction. It will intersect axis of rotation. What all torque will be there only due to mg cos theta and mg sin theta. And what is this distance will be? This distance should be equal to, this should be equal to r, no? So here net torque about point A should be zero. So mg 3r/8. Okay, now this will be mg will get cancelled out. Tan theta equal to 8/3. So the maximum value of theta will be tan inverse of 8 by 10. Simple problem. So just only you should have the ability to analyze the problem properly. Okay, kids. Huh? So almost I think all the different ideas of the toppling I explained. Learn them. Why only like this? The forces are acting. Analyze the equation. How that equations are written. Why only we should take that about point A only because it's having tendency to topple about point A. That's why the net torque about point A should be zero. Okay, we'll meet again with few more better problems in from other topics in coming classes. Okay, thank you, kids. Thank you, all of you. Bye. See you.